Hey everybody, welcome back to another fun and exciting pre-algebra class. Today we are going to continue in chapter number 8. Today we'll be talking about more probability and specifically the probability of what's called an independent event. Okay, this is on page number 389, page 389. In your book, it's 8.5 independent events. Go ahead and look in your book or look down here at the screen. An independent event is a compound event that are not influenced by other events. What does that mean? Well, something that's influenced by other events would be like, oh, if this happens, then this can happen after that. But an independent event is something that can happen and something else that can happen, and they don't have anything to do with each other. The one is not contingent on the other thing happening. All right, here's an example. If Amanda and Brian each flip a coin, so they take their coin here, I got my coin right here, and I flip it up in the air, right? And it lands on heads, for example. What are the chances that Amanda and Brian's coin will both land on heads? Now, if Amanda's lands on heads, that doesn't make any difference of what Brian's is going to do. Brian's could still land on tails. Amanda's coin landing on heads doesn't change the probability of Brian's coin, not whatsoever. They are independent events. They're connected, but they are not dependent on each other. It doesn't depend on what Amanda does of what Brian does, okay? So they're two separate events, but it's kind of combined because we want to know what's the chances that both of them together are going to land on heads. Each of them separately are going to land on heads. So that the events are connected, but the one doesn't really have anything to do with the other ones. They're what's called independent events. Okay, notice that it says to solve this, we would need to find the probability of both A and B occurring. So in probability, when we see the word and, so if we need to get A and B to happen, then that means that we need to multiply. So and means X, or and means multiply, not X like as in algebra X, but as in multiply. So remember last lesson we learned about or. When we see A or B, then that means we're adding. But here when we see the word and, it means multiply. So here's the formula for independent events. So the probability of A, let's call this Amanda, okay? So that is Amanda, and the probability of B, and that was Brian, okay? So Amanda and Brian. Now, they both have their own separate things. So what do we do when we have this word and? We combine their probabilities by multiplication, okay? So what's the probability for Amanda landing on heads? Well, remember, there's one possible outcome that's good, heads, and there's two total outcomes. It could be heads or tails, but we only want heads, okay? So remember, we're multiplying. So what are the chances that Brian lands on heads? Again, one possible outcome, heads, over two total outcomes, heads or tails. It could land on tails as well. So you just do it the way we've been doing it, right? The top is the desired outcome, and the denominator is going to be the total outcomes. So you just multiply this. 1 times 1 equals 1, and 2 times 2 equals 4. So the probability of this happening is 1 out of 4. You could do that 0.25, or you could do that 25%. Okay? So think about it. Here's what could happen. Amanda could get, right? Amanda could get heads. Okay? And then Brian could get heads. So you could get heads. You could have Amanda get heads and Brian get tails. You could have Amanda get tails and Brian get heads, or you could have Amanda get tails and Brian get tails. They both get tails. So notice the only one that's a good outcome is heads, heads, right? That's what we want, heads, heads. And so we have 4 total outcomes and only one. So 1 over 4. That's another way to look at it. Like if we wrote them all down, it would come out the same. But the formula, the easiest way to do it is just take the 2 probabilities and multiply them by each other, and that will kick out the probability of your independent events. What's the important part right here? In probability, and means multiply. Make sure you're writing this stuff down. That is a very, very important thing to write down for when you take your quizzes and your tests. All right, let's go ahead and look at this example. This example is on page 390 in your book, page 390. All right, so here we go. Coupons for free food items and rides were randomly distributed, there we go, I can talk, to each of the first 60 people that entered the county fair. Each person had an equal chance of receiving one of the following items. Hot dog, one of the following food items, I should have written in there. Hot dog, turkey legs, cotton candy, and ice cream. Each person also had an equal chance of receiving a coupon for one of the following rides: Ferris wheel, teacups, and carousel. Now, here's what's happening. They're getting a food coupon and they're getting a ride coupon. They're getting 2 coupons. 1 food, 1 ride. Okay? So, let's go ahead and let's think about this. Now, look at here. There's some important things here. 60 people. Okay? So that's our total is going to be 60 people, right? And then we also had some important things here. The following, so hot dog, that's 1, turkey leg 2, cotton candy 3, ice cream 4. So there are 4 total foods, right? And with the rides, we had Ferris wheel, that's 1, teacup, that's 2, carousel, that's 3. So we have 3 total rides. So there's a couple different things going on. Now, sometimes they give you things in these that are kind of like extra information that we don't really need to know. This number right here, 60 people, we don't really need to focus on that number because none of our problems ask us for like all of the people, okay? So you'll see what I mean here in just a second, but that's kind of extra information. I just want to filter that out right now before we get into these. Number 1, what is the probability that the first person receives? So we're only talking about 1 person. We're not talking about all 60 here. The first person received a coupon for a turkey leg and the carousel. Now remember, these are what's called independent events. Why? Because if you were getting 2 coupons, you were getting 1 for food and 1 for rides. So you're getting 2 coupons. But like, let's say that you get one, you get a turkey leg. Well, that doesn't change if you get a Ferris wheel or if you get a carousel, or that doesn't change your ride coupon, okay? So the food is one thing going on, and the rides are a secondary thing going on, independent of each other, okay? Now, so there's 4 total things with the foods. So let's talk about this. What is the probability that he gets a turkey leg? Okay, so that is 1 thing out of 4 total things. So that would be 1 of 4. 1, the numerator, is the turkey leg. The denominator is the fact that he could have gotten hot dog, turkey leg, cotton candy, or ice cream. There were 4 things that he could get there total. So 1 out of 4 that he got turkey leg. And then we see the word and. All right, that's a key word right there. So we are going to multiply, and then the carousel is the 1 thing that he could get that would satisfy this kind of this arrangement here of turkey leg and carousel. So the only ride that he could only get 1 ride, and that's carousel. How many total rides were offered? 3. So we would just multiply this. 1/4 times 1/3 is going to give me 1 out of 12. There's a 1 out of 12 chance that this guy, the first person in line, would get a turkey leg and the carousel. Okay, now we could divide that out if you want to. I'll just leave it there in the fraction, though. You can take your calculator if you want to and divide and get the decimal and get the percent on that. All right, number 2. What is the probability that the first 3 people all receive a coupon for the Ferris wheel? Now, this one's a little bit interesting because we have to kind of think through this. The first 3 people. So, in other words, let's call them person A and person B and person C. So, person A gets a Ferris wheel. Okay, what's the probability that person A gets a Ferris wheel? How many Ferris wheels were there? 1 Ferris wheel. How many total rides were there? 3. So remember, that's 1 out of 3. So A is going to be 1 out of 3. Remember, this is an and, so that they all receive the coupon for the Ferris wheel. So in other words, he gets a Ferris wheel, and the next person gets a Ferris wheel, and the next person gets a Ferris wheel. Notice that the word and wasn't used here, but that's what it is. It's all of them have to get a Ferris wheel. So he gets one, and he gets one, and the third person gets one. Okay? So we're going to take this and we're going to multiply. And then the B person has a 1/3 chance of getting Ferris wheel. And the C person also has a 1/3 chance of getting Ferris wheel. Multiply that all up. 1 times 1 times 1 is 1 for the numerator. 3 times 3 times 3 is going to be 27 in the denominator. So there is a 1 in 27 chance that the first 3 people all get Ferris wheel, right? All right, now, next. What is the probability that the first person did not receive a coupon for either ice cream or teacup? Okay, so this word right here might be a little distracting to you because you might see the word or and you might think, oh, I need to add because of the word or. Well, let's think this out. Let's think this through and let's kind of figure out what we need to do here. So what is the probability that the first person did not receive a coupon for either an ice cream or the teacup ride? Now, remember what I said earlier about being in independent events. The ice cream is independent and the ride is independent. So in other words, even though it says the word or here, and this one's going to be a little bit confusing for you, and I'm going to try not to totally blow your minds, but this is still an independent event that is talking about ice cream and teacup. In other words, it's like the not receive. So in other words, they received a turkey leg, a hot dog, cotton candy, and, right, there's your and, because then we go to the rides, and carousel or the Ferris wheel. Okay, so the and is there, but it's kind of implied, and you almost have to read it backwards to get the and in there. So it's a little bit confusing here, but in this case, or does not mean add. So you might have to come, and look at some of these kind of and go, okay, what exactly are they asking for? This one's one of those a little confusing. So what's the probability of not getting ice cream? Okay, so that's what you got to think about. Well, he could get, if he did not get ice cream, then he could have gotten hot dog, he could have gotten turkey leg, or he could have gotten cotton candy. He could have gotten 3 of 4. The only one that he couldn't have gotten was the ice cream, right? The 1 out of 4. So the way that we're going to do this one is we're actually going to do it with the 3 out of 4 because those are the desired outcomes. The ice cream's not a desired outcome. Why not? Because he didn't receive. Notice it says he did not receive. This is like a backwards problem. Everything about this is backwards because it's saying he did not receive the coupon for ice cream. So there was a 3 out of 4 chance that he did not receive the coupon for ice cream. Now, and he also could have received what? He could have received carousel or he could have received Ferris wheel. So he could have received 2 of the 3. Remember that 1/3? That's the one that he couldn't. That's the teacup. The teacup is the 1/3. So we had to kind of subtract that 1/3 out. Okay, so we get 2/3. He could have gotten carousel. He could have gotten Ferris wheel. He just couldn't have gotten teacup. Okay, and so now we would multiply these together. 3 times 2 is going to give us 6, and 4 times 3 is going to give us 12. That's going to reduce out to 1/2 would be the answer there. That last one, a little bit confusing. I get it. Maybe you struggled through that one to kind of understand what the question was asking for. It's okay. But just take the time when you're reading these and try to figure out, okay, what are they really trying to get me to do here? For the most part, the word and is going to mean multiply. The word or is going to mean add. Every once in a while, they might mess you up by kind of slipping one of those words in there to try to confuse you and try to throw you off. But make sure that you really kind of get what they're going for, think through it, and then put your probabilities, your fractions in there, and then multiply or add based on what you need to do. In this lesson, for the most part, you're going to be multiplying, but then on quizzes and tests, you're going to have to figure out, okay, do they want me to add? Do they want me to multiply? And you do that by figuring out, by reading the question and trying to understand, okay, what exactly are they asking me for here? Okay? Well, that's all I have for you in this lesson. Hopefully you learned something there. If you missed anything, make sure to slide it back, watch it again. Practice some of these. Go to these practice problems and try these. Try to get these figured out so that you can know how to do these on your quizzes and tests. All right? We'll see you later. Have a good one. Bye-bye.